So we're in this packet that y'all did last Friday, and we're just starting this example. Okay, sorry, I forgot to record at the beginning. Okay, so first derivative, can you just tell me what it's gonna say? I'm ready. Okay, negative 4x3 minus 24x squared minus 36x. Okay, then from there, before I set that equal to 0 and kind of get into the weeds of the first derivative test, let's just take the second derivative right next to it. So derivative one more time, what's it going to be? Okay, negative 12x squared minus 48x minus 36. Okay, from here, the mechanics of both tests are identical. We're going to set it equal to 0, and then we're going to do an interval test. So let's set this one equal to 0. What can I take out of all of those terms? Negative 4 and an x. Very good. Remember that if there's ever a negative on the first term for factoring, you always want to pull that out. So I'm going to have an x squared left. What will the negative 24x squared leave behind? Plus 6x. Very good. And then 36 divided by 4 is going to leave me a 9. What kind? Plus 9. Very good. So from here, I want to see if I can break that down one more time. So maybe we could do this in our head. We need numbers that will multiply to 9 and add to 6. 3 and 3, very good. So I'm going to have x plus 3 and then x plus 3 again. If you want to give yourself the little AC chart, you can. Okay, but it'd be 3 and 3 to give you 6. Now, the other way that I could write that if I want is instead of having x plus 3 twice, I could write it like this. X plus 3 and then. All right, let's identify the solutions to this are going to be called the critical numbers. So if I have an x on the outside, what is the critical number going to be? Very good. X equals 0. And then x plus 3, what's my second critical number? Negative 3, very good. So 0 and negative 3. Now, because I know that I'm eventually going to do like 2 line tests and put them on top of each other, I'm going to actually do my line test here to the side. So I'm going to give myself a little line right here. And this is going to be for f prime. But give yourself a little bit of space because we're going to do another line test right below. Okay, 0 here, negative 3 here. Okay, make sure they have to go in numerical order along your number line. Then I need a number bigger than 0. What could I pick? 1 is great. You're plugging into here, and you want to check the overall sign of how it would come out. So if I do 1 plus 3, what's the sign? Positive, then square it. Positive. Okay, then I'm going to times my 1 by a negative 4 on the outside. How will that come out? Negative. Very good. So a negative times a positive is overall negative. And remember, that tells me that f is going downhill. Because f prime tells me the slope of what the original function was doing. Between 0 and negative 3, what could I pick as a test point? Negative 2. What's negative 2 plus 3? And then I'm going to square it. So positive. Okay, then I'm going to take that same negative 2 and I'm going to multiply it with a negative 4. Positive. And so if I have a plus times a plus, that's going to be big plus. That tells me f was uphill on that interval. Smaller than negative 3, what could I pick? Negative 4 is great. Negative 4 plus 3 is negative, but then what's going to happen when I square it? Going to turn positive. And then a negative times a negative on the outside, that's going to be another positive. Multiply 2 positives, get a big positive, which means uphill. Okay, now this is enough information for me to tell where the graph is increasing. The problem is I don't just want it to be increasing. I also want it to be concave up. So let's do our second derivative test. So set this guy equal to 0. What can we take out of all those terms? Negative 12. That's going to leave me with an x squared. My minus 48 divided by negative 12 is now a plus 4x. And then negative 36 divided by negative 6 is going to, I can't talk. What is it going to be? 3. Okay, then I need numbers that times to 3 and that add to 4. 3 and 1, very good. Okay, apologies for going through these charts maybe too fast, but 1 times 3 are going to be my guys because they also add 4. So I have x plus 1 and x plus 3. What will my critical values be for the second derivative test? Very good. Now, question. Someone did this in the other class that they also listed 0. Should I also list 0? No. Remember, a 12 on the outside only gives you 0 as an answer if it also has an x. X's are where we get our answers from. Okay, so on your number line, when you draw it below, I want you to make sure your negative ones line up right on top of each other. So for my second derivative, sorry, I meant to say negative 3's need to line up right on top of each other. Okay, and then my negative 1, we'll kind of put it right. Thank you. All right, then from there, this is going to be f double prime. And remember, I work it out the same way, but what I draw on top, instead of being up and downhill, is going to be concave up like a cup or down like a frown, which is what you did on that last day of notes. So pick a number bigger than negative 1. What's a really easy number we could pick? 0 is great. What is 0 plus 3? Positive. What's 0 plus 1? What's negative 12? Negative. So if I have a minus plus plus, that interval is going to come out how? Big minus, which means concave down. Between negative 1 and negative 3, say I pick negative 2. Negative 2 plus 3 is positive. Negative 2 plus 1. Negative 2 plus 1 would be negative. And then I also have a negative 12 on the outside. So that's a second negative. So it's minus, minus, plus. What's that overall sign? Positive. And if it's a big positive on that interval, what's the concavity? Up or down? Up. Very good. Okay, then last little section, less than negative 3. Say I pick negative 4. Negative 4 plus 3 is negative 4 plus 1 is negative, and 12 is also negative. So if I have minus, 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 2 of them can cancel each other out, but that third one is going to stick around to give me overall minus, which means concave down. Okay. Then from there, we're looking for it to be both increasing and concave up. So that means that I want increasing is here and concave up is here. And then I'm looking for the overlap. So where are both of those things going to be true? Very good. Just from here to here. So it would be from negative 3 to negative 1. And then I'm going to put because f prime and f double prime both positive. Okay. Overall, we feel like we kind of remember that a little bit. Okay. So I did do number 7 in first period, but their class was really long. So I think I'm going to skip it. And we'll go to this very last page. Okay. So turn to this guy right here. Okay, so concavity so the second derivative can tell you about concavity, but it also has a couple other uses. Another use is if you're dealing with very limited information. So what I mean by that is like, let's say that they give you like a chart, but you don't actually have the equation. Okay, so if you have limited information, knowing the first and second derivative, you can actually tell whether you have a min or a max. So if you come up here to the top, okay, if I know that f prime of 3 is 0, that tells me that I have a horizontal slope. Right? Anytime that the derivative is 0, I know that I have a flat spot, and horizontal slopes are one of the only places that you can have mins and maxes. Okay, we learned that long ago. Okay, so if I also know that the second derivative is less than 0, is that positive or negative? Less than 0. Then I also know my graph is concave down. Then essentially what you end up knowing is that you have a down like a frown graph and you're on the flat spot. What would that automatically make that point? Okay, it is tangent, sure, but is it a min or a max? It has to be a max. So if you know you're at a flat spot and you know you're in a concave down section, then you have to be at a maximum. So it's kind of like a little sneak that you could still figure it out. So I'm going to put right here a horizontal tangent within a concave down section of the graph has to be a relative maximum. Because if I'm on the flat part of the little frowny face, then I have to be at the highest point on that graph. Okay, conversely, okay, if I have a derivative of 0, that means I'm on a flat spot and my second derivative is greater than 0, then my graph has to be concave what? Up. So I'm on the horizontal slope and I'm concave up like a cup. Then draw me a little happy face, find the flat spot on it, and you must be on a relative what? Minimum. So if you ever have that combination, that's another way to check if you're on a max or min. So now let's look at, this is just a free response question off of an AP test. Okay, and let's use that information for part A. So first thing it asks you to do is identify your critical numbers. Remember that critical numbers are anywhere that the derivative is 0 or undefined. Okay, a critical number is anywhere that the derivative is 0 or undefined. Now, when you look at that table, you've got 3 rows. You have a regular F, you have an F prime, and you have an F double prime. If I want to find the critical numbers, which row do I need to be on? The prime row, and then I want you to find where it's 0. Where does that happen? Okay, it happens here at x equals 2, and then again here at x equals 4. Very good. So write down x equals 2 and x equals 4. Okay, so let's read the instructions again. It said to identify the critical numbers. We did that. Remember, critical numbers could be a max or a min. Okay, then it says identify it as a min, a max, or neither, but use the second derivative to justify your reasoning. So let's come here to 2 first. My first derivative is 0. What is my second derivative at that same point? What type of number? It's negative. What does that tell me about concavity? Down. Picture a frown in your head. What type of point is the flat spot? Max or min? Max. Very good. So let's put this has to be a relative max because F double prime at 2 is negative, meaning F is concave down. Now, if you want to draw yourself a little picture, okay, to show that that's the max, you can. But as far as the AP test goes, like drawing a picture doesn't count. I mean, you could do it, but they're not going to like be like, ah, yes, they understood and give you points for it. All right, let's do the same thing for 4. So at 4, I see my derivative is 0. What type of number is my second derivative? Positive, which means what type of concavity? Up like a cup, which means what type of extrema is it? Minimum. Very good. So I'm going to put this as a relative minimum because F double prime at 4 is positive. And that means F is concave up. And then if you want to draw a picture, you can. But remember, they're not going to grade it. So if you have a critical number and you happen to also know the concavity, that's enough for you to say, oh, it's a min or max. All right, let's keep going and finish out the question. Part B says, find the values of X for points of inflection. What row will I find inflection points on? F, F prime, or F double prime? Points of inflection are going to be the F double prime row. So I want F double prime of X to equal 0 or DNE and change sign. Okay, because if you remember from those notes, an inflection point means that your curve is changing from being concave up to down or down to up, but there does have to be a concavity change. So look in your F double prime row. Where do I have a 0 or a DNE? What X value? Okay, right here at 3. And then around that point, does it change sign? Everything on the left are what type of numbers? Negative, which would have meant concave down. And then on this side, they're all what? Positive. So I would say that X equals 3 is a point of inflection. And point of inflection and inflection point are the same thing. Okay, last part of this is the hardest. We're going to practice this twice. Okay, so what it's asking you to do is to draw a picture of what F must look like. So we're going to do this in 3 steps. The first one is that we're just going to place points. So using your chart, can you tell me what the Y value is at 1? It is 3. And you see right here that at 1, it says F is 3. So I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3. Place my first dot. So at 1, F is 3. That's my Y value. Can you tell me the Y value at 2, please? So 4 or 5. Put a dot about where 5 would be. Doesn't have to be perfect. Next, we're going to 3. At 3, what's my Y value? Also 3. So these 2 points should kind of match each other because they're both 3. Doesn't have to be perfect. Okay, at 4, what's my Y value? Drops down to 2. At 5, what's my Y value? 4 would be about here. And then at 6, what's my Y value? So we'll just say 7's up here. Okay, so first thing we do is we just go ahead and put those dots on our graph. Because we have at least a few points. But then the question is, how do I connect the dots to match the rest of the information in the table? So here's what I'm going to have you do. We're going to use the table to make a first derivative test and a second derivative test. We're going to do it over here on the side. So give me an F prime line and then an F double prime line. Now, let's go back to our information we already did in part A. what were my critical numbers for the first derivative test? This is for part A. 2 and 4, very good. So 2 we'll put here, 4 we'll put here. What type of extrema was 2? A maximum. Then it must have changed from uphill to downhill. And then what type was 4? Was a relative minimum, so it must have changed from downhill to uphill. Okay, now let's do our F double prime row. Now we're talking about concavity. I only had 1 point of inflection. What number did it switch at? This is now part B. Happened at 3. And then go back to your chart and tell me, what direction did F double prime change sign? Did it go from minuses to pluses or from pluses to minuses? Very good. So if you look back up here, it's minuses. Then I hit that spot and then it goes to positives. So that tells me that my graph went from a down concavity to a up concavity. Okay. This is enough information for you to correctly connect the dots that you drew on your picture. So from 1 to 2, okay, and listen to like the phrasing so you can kind of think about it. From 1 to 2, am I going uphill or downhill? Uphill. And am I concave up or concave down? Downhill. So I want you to draw a connector, uphill, concave down. But you're using both of those 2 pieces of information to draw the segment. Okay, next, from 2 to 3, I want to be going uphill or downhill? Downhill. And how do I want to be downhill? Oh, that was too dark. Oh, well. Okay, I'm still concave down, right? So make sure when you connect it, you want to be downhill and concave down. All right, next section. From 3 to 4, uphill or downhill? Downhill, but what concavity? Up. So I want to be downhill, but bent up. And then last little bit of this, I want to be increasing is uphill. What type of bend? Up. So I want to connect those like that. Yes. Question?
Yeah.
So you can connect the dots. Normally though, on the AP test, they won't give you the dots. So I tried to pick an easy one that has it. Now, keep in mind that what if you connected these dots in a straight line? Then you don't have the concave down. Or if you connected it this way, you see what I'm saying? So it's like, yes, you kind of can, but a lot of times you won't have those Y values to like anchor your picture, if that makes sense. Okay, questions on that? Okay. We're gonna move on to do one more of those, but it's in a different packet. I promise I won't make you take notes the whole time. And you don't have any homework. You don't. For one day, guys.
Well, see, this I wanted to overthink it, right?
So you have the extra credit homework from a while ago, and then you have the first derivative test. But you can finish.
Step back. Whoa. I'll sit down. It's like an update.
Oh, you just start. Yes. I only have a yucky brown paper. You want that? You have tissues?
Will you assign the homework due in Thanksgiving break so it's not canceled out?
Huh?
Will you assign it homework in Thanksgiving break so that can get?
I will extend it. I will extend it to whenever you do it. I will take the late penalty off, but I just had to type in break, you know.
If you had to have known that, I was
Almost. We just have to do a little, like a little tiny bit more. We're almost done. Okay. All right, let's do one more of these and see how we do. Okay, do part A. You can do it. Huh? That's okay. You're doing great. Okay, the structure of this question super similar. You're finding mins and maxes. Okay, then you're finding inflection points. Okay, you should be able to do it. This is
I think it's either 50 or 5.
Okay, so are we finding our critical numbers? Okay, that's where the derivative is 0 or. Yeah. So where is it 0, which depends on it? And what x? One. Okay, and then anywhere else? Okay, so x equals. And then anywhere else? Okay, now we need to know which type of. So here, it goes from positive to positive. Does that count as a min, a max, or mean? It goes uphill, and there's a uphill. So put neither next. Even though it's a critical number, it's not a min or a max. Okay, now let's do your second one, which was how does this slope change around from to negative? So it went from a positive slope to a negative slope. That makes it a min or max. So write that. Oh, it's not a good. We are going to draw it down here, but you can draw it. Yeah, 3 is also a critical number. So it should be 1 and 3.
Is it not one?
Oh wait, is it? Oh no, I'm sorry.
That's the
30. What's the second?
Hey.
I'm sorry.
Oh.
So see how it's not 0. Now it is 0 up here. Yes. We're gonna look at the signs and how that sign changes. So remember, if you guys think about it, it goes from positive slope, it flattens out, and then it stays positive. So it has to actually have a sign. So think about it, it goes from a positive slope, 1% positive slope to a negative slope. So you can also use the concavity check sometimes, or do you have to use that? Can we write the neither? You can put neither, but I don't think it would penalize you if you didn't put it. Oh. With part A.
You go here. I didn't see you.
So if you're doing minimum and maximum, then you're going to get primer, so it's clear, we're at 1. The year 2 and then you have 2 choices. Sometimes you have to put And it goes from minus to plus.
Smiling face.
Now, what if it goes from like plus to okay?
Oh, why is there one ball? There's two. They just touch. That's how you make out.
Yeah. So then what? That's where you can see the number is like negative. And then the other one is.
Where is that? Shadows.
And you're looking at where it changes from, so it doesn't just have to be like. I think there's three. So you go from negative to positive at one. And then from positive to negative at two, and then negative. Well, you're just looking at that. Yeah. Now you do have one little issue actually, and you do.
Those who know.
So go to one, your F prime is 0, yeah.
What?
What is this, what is F prime?
You need help me on your win.
What happens after?
That's cat.
Still positive. So if your graph goes like this. So you might have to list it in. Okay, just in the interest of time, I want to go over A and B and then we're going to do C together. So for part A, extremum, if you're not sure what that word means, okay, that's plural for extrema. Okay, and so that would just basically be maxes and mins. That's what they're asking you for. Okay, so I'm looking at the F prime row. Where are my critical numbers that my F prime equals 0 or undefined? X equals 1 and 2. Okay, because at 1, I have an F prime of 0. And then at 2, I have an F prime of D and D. Okay, from there, check if you look at your concavity and it's inconclusive. So for example, what is F double prime at 1? Is it positive or negative for me to use that concavity check? No, then I have to look for a sign change. So before 0, what types of numbers did I have for F prime? And then after 0, what was it? Still positive. So if you want to come down here, since we're already talking about it, okay, let's put 1 on our number line. And it went from plus to plus. Okay, then at 2, what type of numbers do I see after 2 in my F prime column? So it goes from positive to negative. So that means that my original F graph goes from increasing to decreasing. So what type of extrema is 1? A min, a max, or neither one? Neither. So I'm going to put X equals 1 is a neither. And then I'm going to put F prime doesn't change sign. Normally you could check concave up or down, but because F double prime at 0, it doesn't really like tell you what the concavity is. So you couldn't use that option. Okay, for my second number was X equals 2. It goes from plus to minus. That makes it what type? Relative max is correct. Because F prime changes from plus to minus. So 1 ended up being a neither. 2 ended up being a max because I went from uphill to downhill. Let's go on to part B. Now, which row am I looking at? Not F prime, but F double prime. And I see that I have a 0 here here and a DNE here. However, remember that they only count if there's a sign change. So if I look here, I went from negatives to positives, then to negatives to positives. Did they all have sign changes? Yes. So I'm just going to list them out. X equals, that would be 1, 2, and 3. And then I'm going to put because F double prime changes sign. All right, now we're going to turn that into a second derivative test, because if you see in part C, in the third part of the question, we're going to have to draw the graph. So let's draw our number line here. Try to line up your 1 and your 2. And then we're going to have to state what the signs are on each interval. But remember, since I have a graph, I'm just kind of picking the numbers. I'm not having to plug anything in. So before 1, what was the F double prime row? Positive or negative? This section right here. Before 1, what was the F double prime row? Negative. Then it switched to positive, then positive. Now, if this is F double prime, that tells me concavity. So my graph needs to start concave down, then up, then down, and up. And that is going to help me connect my dots. So I want you to try this next part. Draw your anchor points. You're going to pull them from the regular F row, and then you're going to use this to connect the dots. So what I mean by that is, what does it tell me the Y value is at 0? So you should be putting your anchor dot here. And then at 1, what does it tell me the Y value is? Okay, you get it? All right, we'll check it here in a sec. So get the rest of your anchor points and then connect your dot.
Yeah. No.
It's very similar to what the but then in the spring. Okay, good. So from 0 to 1, is it increasing or decreasing?
Oh.
So you just want to draw an uphill graph. That's been. Now, if you would just connect to the dots, you would miss this closer. What is your uphill? Wait, right. We have this wanted to be little weird stuff going on, but it's mostly. And then don't like curve it in on so otherwise it's oh, that's good. That's very good. Hold on, I want to come see it. I want to give you a wow. So you got a bed? Does it matter? Yeah, so you have to concave it the correct way. So it's either up like a smiley face or it's going to be curved down like a Yes? Yes. No, except you didn't finish it. What about 3? Gonna still be down. All right, let's see your graph. Okay, ready? Okay, from 0 to 1, you should be increasing concave down. From 1 to 2, you should still be increasing, but concave up. Okay, then you should switch to decreasing concave down. And then still decreasing, but concave up. All right, now real quick, before we go on to the last thing, we're almost done. Okay, is you should check your work for A and B and make sure that they're true for your graph. So at 1, do I have a flat spot, but it's not a min or a max? Yeah, see how it flattens out here? Okay, but then it keeps going up. At 2, do I have a relative max? Yes. And then at 1, 2, and 3, does my concavity change? Yes, down to up, down to up. So yay, you did it. Great. Okay. All right, skip ahead to this page, please. You thought. Okay. All right, I'm going to run through the last part of this quickly so that we have at least 30 minutes left. But I need you to kind of lock in so that we can do it quick. Okay, in your diagram, we have various combinations of F prime and F double prime. Okay, I'm fixing the last one, otherwise these two would have been the same. So I'm going to do this bottom corner with you, and then we're going to do the other 3. So if I want F prime to be less than 0, do I want increasing or decreasing? Decreasing. And if I want F double prime to be less than 0, what concavity do I want? Concave down. Very good. Can you draw me a little piece of graph that's doing that? Decreasing, and it's bent concave down. Your graph should look like this. Okay, right next to it, I want F prime less than 0, and I want F double prime greater than 0. Do I want increasing or decreasing? But if I want F double prime greater than 0, what's the concavity I want for this box? Concave up. Very good. So draw that, a decreasing graph, but that's bent concave up. A decreasing graph that's bent concave up. It should look like that. All right, top 2. Let's do top left first. F prime is greater than 0, increasing or decreasing? And what's the concavity for this box? Concave up. Draw that. Should look like that.
Is it? It's good if it does that.
No, because you want it to be increasing the whole time. So if you draw both sides, it has a down and an up. So you're having to like pick the piece of the smiley face that's uphill, if that makes sense. Okay, then last one, I want the first derivative greater than 0. That means increasing. But then I want the second derivative less than 0. That means what? concave down. So I want it to be uphill, but bent like a frown. So I want it to be like that.
Oh.
Okay, out of those 4 graphs, I want you to put a little star next to the 2 that are getting steeper. Steeper. Put a little star next to the 2 that are getting steeper. Okay, this is one of them. And which other one? 4, very good. Okay, for both of those boxes, okay, for both of the boxes that you picked, do you notice that your first and second derivatives share the same sign? They're either both plus or both minus. Okay, so come down here and I want you to write a function's graph will be getting steeper when f prime and f double prime have the same sign. So one of the ways that the AP test will try to trick you is that they'll ask you questions about it, but they'll give you a table to try to match. So let's just look at this question. I think we have 4 of these. Okay, I want a positive first derivative and a positive second derivative. What should my graph look like? Should it be increasing or decreasing? Increasing, and what should the concavity be? Okay, I'm going to put CCU for concave up. Okay, can you draw me a little segment that looks like that? And then tell me if it's getting steeper or flatter. Increasing and concave up is a graph that should be getting steeper. So out of the tables listed below, which one is not even increasing? Increasing meaning the numbers are getting bigger each time. Okay, D is out of here. This is a decreasing graph. Okay, out of the remaining 3 graphs, you're going to count the jumps and see if they're getting bigger or smaller. So for example, on A, 6 to 8, how many did it go up? 2. 8 to 10, how many did it go up? 2. 10 to 12, it went up. 2. Are the jumps getting bigger for it to be getting steeper? No. Let's go to B. From 6 to 10, what's the first jump? 10 to 13. 3, 13 to 15. 2, are those jumps getting bigger or smaller? Then this graph is flattening out. Okay, and I don't want it to be getting flatter. I want it to be getting what? Steeper. So look at the last one. 6 to 8 is plus 2. My next jump is plus 3. My final jump is plus 4. This is a graph getting steeper, which means that C is my match. Okay, do one more off the next page. Read what the combination is. So it's going to tell you the first and second derivative signs and then use that to pick which one you want. The top one.
That could be decrease. So we can eliminate D. This one would be less. No, it's not. It's right in and out, like this. Right.
You want it to be negative first derivative, so increasing or decreasing? Decreasing, and what's the concavity? Concave up, so then it has to be like that.
Oh,
So is it getting flatter or steeper?
flatter.
So you want to pick a decreasing graph where the jumps are getting smaller. And you can automatically get rid of D because that one's going the wrong way. See, you did 3, then 2, then 1. Yeah, that's right. Too good. Too good. Okay, for number 2 at the top, you should have picked C. For number 3, should we be, we're increasing at a decreasing rate? Does that sound like getting flatter or steeper? It should be C. It should be flattening out. So it'd be down 3, down 2, down 1. Do you see what I'm saying? You see what I mean? So if it's increasing at a decreasing rate, it needs to be going uphill, but a decreasing rate means flattening out. So I need my jumps to be getting smaller, and there's not a graph that does this, so we're going to just change it so A works. So if I want it increasing at a decreasing rate, let's say that I go from 20 to 24. Then what would the next jump have to be? It would have to be a jump of less than 3. So maybe I could jump 2 to 26 is great. And then what would the next jump be? 27 is fine. Okay, but they don't have to go in order, but they have to be getting smaller. So this one I jumped 4, then I jumped 2, then I jumped 1. That would be an example that would fit the criteria. Does that make sense? Okay, look, you have almost 29 minutes. Pretty close. Okay, just get stuff done. Be productive. You don't have a new homework. If you need to work on your extra credit, this is the last day week that I'll take it. Yeah, the extra credit that I had given y'all for the last test. It has chain roll, it has implicit, it has really great. You know? And then Rebecca, you should do some of the second derivative test homework. I don't want help.
I still need to make my free response test.
Now, what do you think?
I need to like look at the review.
Okay.
Thank you. But I'll also be going on Thursday and Friday.
Okay. So let me give you the notes for Thursday. So you just already have the paper. And then this is gonna be the last new thing that we do. Before. So then, you have like a class. Because I mean, I'm fine with you finishing the test later, but you're just not gonna have time to correct it.
Yeah, so when I maybe
So like second, fourth, sixth. What do you have 6? What teacher? Do you think she'll pay it? Okay, email her and ask her, and then just include me in the email so I'll see her response. But I'm good with that.
Okay, and I don't think I'll need like a ton of time, so I could even go to her class and like do whatever I need to do and then come and take.
Okay, yeah.
You actually only get 15 minutes. Yeah, I think I gave them. Did you already start it?
I think I gave them 40. So I would say as long as you have that long. Okay. All right, be productive. Why are we in Tom Thumb? We don't need to be in Tom Thumb. We need to be in productive things.
No. That's so weird.
Yes.